This video is about the states of matter, so what physical state matter can have. The states of matter common on Earth, we have seen them since kindergarten. We can identify them, but let's see if we know all of the characteristics. For solids, which would be this ice cube that I have over here, they have a definite form and volume. They are rigid and they resist to forces that can modify them. If you touch them lightly, they won't change. It's not until you crush them or you apply a lot of force that you can actually change the shape. But if you leave a solid to be a solid, they will not deform. They will keep their shape always. Liquids have a definite volume, but an indefinite form. They can take the form of the container that holds them. So for example, this liquid that is here could be taller if we have a taller container, right? Or it could be smaller if it have a smaller container, right? And all the liquid would be here. So I'm not changing the volume of the liquid. It would still be 10 milliliters, 10 milliliters, and 10 milliliters, but the shape will change. They are incompressible, so you cannot push to them and they can't expand indefinitely. And the last one, it is the gas, right? The gas state. It does not have a definite form or volume. It can be compressed and it has low densities. That's what happens, for example, if we have smoke. And if we have smoke in a room, it will take the shape of the room and it will take it all, right? But if we open another door to another room, it will also expand and it will take the shape of my whole house and also the volume of my whole house. So let's see these drawings over here. In this drawings, what we can see is how apart the molecules are. So if you see in a gas, we have a lot of space between molecules, right? Gases have a lot of energy and their molecules move, right? So they move a lot and they take up all of the space that they want because they're moving. As we go from a gas to a liquid, we can see that the molecules are not that far apart, right? So that's why we cannot compress them because they are already taking up space. So here the energy is lower. So if we have 3, here the energy is lower. They're not moving that much. And when we go from a liquid to a solid, we can see that there's not that much space between them, right? They are already in their place. That's why their form does not change. And the energy of a solid is very small. They just vibrate and they keep into place. They're not moving around like a gas. So let's see some characteristics. Very important. These are common on Earth. We have more states of matter, but the ones that we see on our everyday are the ones that we see on our everyday are gas, liquid, and solid. So let's see the comparison of some of their characteristics. So we already talked about shape and volume. Solids have a definite shape and a definite volume. Liquid have a definite volume but not a definite shape. And gases, they can take up all of the volume and they can be whatever shape. What about the arrangement of particles? That is the last thing that I talked on the other slide. When we have a solid, the particles are fixed because they're very close. When we have a liquid, they are close, but they can move around. Their arrangement is random. And on a gas, we have a random arrangement and they're very far apart. That's why they can take the shape of the container and the volume of the container. What is the interaction between the particles? If they are fixed and very close, obviously their interactions is very strong. As we have more energy, their interaction is less strong, right? Because they're not so close by. So in a liquid, we have a strong interaction, and with a gas, we have no interaction. Essentially, none interaction between the particles. And this interaction also has to do with the energy, right? Solid particles do not move. They move very slow. Liquid particles are moderate. They move some because they have some energy. They can move around. And gas molecules move super fast. And what are some examples? For example, in a solid, we have ice that we saw on our first slide. We have salt. We have salt crystals. We can see them when we put it on our food. We have iron. For a liquid, we have water, of course, oil, vinegar are some examples. And for a gas, we have water vapor, helium, or air. Those are gas examples. So I told you that it's not everything solid, liquid, or gas. We have some other states that are not very common on Earth. One of them is plasma. Plasma is when the electrons stop rotating on its nucleus and move freely. They are freer. So if we have solid, liquid, gas, then we have plasma. So plasma has much more energy. They can move around a lot, right? They move freely. And we can see it in the stars, obviously in the sun. We can see them in the northern lights. We can see them in lightning. And we can also see them in this neon signs. This neon signs, that's an example of plasma on Earth, right? So these three are on Earth, and this is obviously not, right? And on the other hand, we have the Bose-Einstein condensate. It exists near the absolute zero. So we would have the Bose-Einstein condensate, then the solid, then the liquid, then the gas, then the plasma, if we were talking about more energy. So the Bose-Einstein condensate, it is so cold, so cold, that the particles stop moving and they just condense in a place. So remember, if these are atoms, we have the nucleus, but we have the electrons moving freely, right? But for electrons to move, you need to have energy. So if we have no energy and they're not moving, so that means they will just fall into one spot, and that spot is the condensate. So those two states of matter are not as common. We have not studied them that well, but they do exist, and we can see some examples of them. Why do we have so many different states on Earth? Because we have energy, and the transition is due to a change in temperature. So we have some transitions. We have the melting point, the boiling point, the condensation point, the freezing point, or crystallization, it's also called, or deposition. So we can see it says our melting point is the temperature when it goes from a solid to a liquid. So we have more energy, right? The transition here is that we need energy for a solid to become a liquid. We can see, for example, melting butter. So we have our stick of butter, we apply heat, and then we have melted butter, right? So this would be butter. We can do that for water also, for anything that is solid. The boiling point is when we already have a liquid, but we wanted to turn it into a gas or a vapor. So what do we need for this to happen? We also need energy. What about the condensation point? It says a gas becomes a liquid. So we're going the other way, right? So we need to take away energy in order for a liquid to become a gas, for a gas to become a liquid, and our particles are closer and closer. The freezing point is taking it one step behind, because it's when a liquid becomes a solid, and we also retrieve energy. So we take away energy for our liquid particles to be closer together for it to make a solid. And deposition, it's a funny case because a gas becomes a solid without even going through the liquid part. So we're not going through the liquid, we're going directly from being a gas to being a solid. So we have here several changes of state. Let's start with a solid. If we go from a solid directly to a gas, it's called sublimation. Some iodine particles do it. If we go from a gas to a liquid, it's called condensation. What we see on cold mornings in our windows, for example, cold mornings on windows, or for example, in a cold glass of water, you would have water droplets condensing in your glass. If we go from a liquid to a solid, it's called freezing. So whatever happens in our freezer, we can do, I don't know, ices, we can do ice cream, etc., right? So we take it from a liquid to a solid. Okay, so we have one side. Let's go through the other side. If we go from solid to liquid, we apply energy, right? So we melt it. So I already told you about butter melting. How do we change some minerals into things that we can use? We melt them in an industrial oven. How do we go from liquid to a gas? We evaporate stuff when we're cooking. All of the time we want to evaporate water or evaporate the wine that we're cooking our meat in. So that's evaporation. And when we go from gas to solid, it's called deposition. That happens in your freezer because freezers have water molecules like gas molecules because we have humidity. And when you put whatever thing that you put, a bag of something, and you can see that it has frost, it is because of deposition. This water droplets never went to a liquid form, they just deposited as frost in the bag that you have in your freezer. So that will be an example of it.